Hi, welcome back, boys and girls. It's Miss Tamal here. And guess what? Today we're going to get to do something oh so sweet and tasty. And we are going to the Moltastic Ice Cream Parlor. So, and if you are ready to sample a few flavors and refresh your memory about mold, grab these three items: your marble notebook, so you can use it for scrap paper, your pencil, and then your packet. This is lesson 11. Again, this is math lesson 11. When you're ready to sample some flavors, go ahead and press play so we can start with our do now. All right, so for our do now, we're going to keep our algorithm skills oh so fresh. And in order to do so, we're going to practice what we've already learned about borrowing or regrouping. 768 minus 489. 658 plus 705. 758 minus 645. Go ahead, pause this video for 3 minutes and you can go ahead and either borrow or regroup as you add or subtract. Let's brush our shoulders off. Brush your shoulders off. We just did that. Now that we just refreshed our palettes, we're going to go ahead now and look at a student example of mole. So this student's work is an example of work that we can all do as we look here. So when this person solved this problem, this is the work that they did to match their thinking. Brianna jogs 15 minutes more on Sunday than Saturday. She jogged 26 minutes on Saturday. How many minutes does she jog on Sunday? How many minutes does she jog in total? What parts of mole did this student master? Go ahead, take a few minutes to just look this over carefully and then jot down your thinking. And then we're going to come back together and share it out loud. All right, so you had some time to look it over. Let's hear what you noticed. This person noticed that the numbers were circled in the problem. Good job. Units are labeled and then the question is bracketed. Yes, let's take one more. I see you with your hand in the camera. Yes, go ahead. There's a key for each one. So you all are ahead of me and notice some of the things that I also noticed, but let's go ahead and get this all down together. So circle the numbers, we saw that right away. Underline the units, labels from the questions. Yes, we see those units here, so we know what the numbers would represent. Labeled each question with an A and B, so we know that there are two unknowns that they were solving in the final question, and then they also labeled their spaces A and B to match that. Wow. Now, when we think about the keys, which you also pointed out, they made two keys here to match the steps or the thinking that they were doing in each step. Each key has the action and relationships, and I'm noticing that each key also has labels within it. Then next, that person did their equation, and it's right there with the components of the key labeled underneath it. This person did not forget to have a final answer sentence, which is a complete sentence with the character's name, and then also labels for the units. And then all of the work is shown. And then this person deserves a 2 thumbs up because they also did a double check just to make sure. So let's give this person a 2 thumbs up. Good job. So we can go ahead now, and as we start to just refresh our memory around mole, we're going to have a quick mole review. There's been some upgrades in this Moltastic factory, so we want to catch all of them. You can go ahead now and look on page 1 because that also has, you can look at page 2 because that also has all of your mole steps so you can follow along with me at this problem. Let's now go over to the M. All right, so with our M, we want to start off with marking up the question. M stands for, yes, mark it out. And when we mark up the question, we want to read the problem at least 3 times. How many times? How many times? Yes. How many times? Now everybody, how many times? 3 times. And so when we mark up the problem 3 times, here's what we're doing on each time. First, we want to visualize, create, and think. What is happening in the story problem? What information do I need to solve this problem? What steps do I need to take? Which operation matches the action or relationship? These are all the things I'm visualizing or creating or thinking about in my head so that I can really understand what's happening between each sentence in the story problem. Here's our second read. On the second read, we're going to read it again, and then that is when we mark up using cubs, because now we really understand what's happening in the problem. So now we can mark it up. C, circling the numbers. U, underlining the units. B, bracketing the question. And then S, writing our final answer sentence. Now here's our last read. In our last read, we want to read it again and then create our mini unknown box. Within all 3 of these reads, we're going to keep reading it slowly so that in our minds, we're digesting what's happening in the problem. All right, let's head over to our O. O stands for organize your work. It stands for. So when we organize our work, we want to set up our workspace with titles for each step. We want the person to know, and it's helpful for us to match our thinking to our many unknowns so that we know that at each step, this is our end goal of solving that many unknown. And that is why we will use the many unknowns that we come up with as the titles. It's going to help us remember, what are we solving in this step? As we create multiple steps, we want to draw a straight line to divide each step. And then we create a key and fill in our knowns and unknowns with the units within that key box, just like that scholar did in our example. L stands for label and show your work. It stands for, good job. It stands for label and show your work. It stands for. Okay, so when we label, we want to circle and label your final answers for each step. And then also you want to include the correct units. Now, as we show our thinking, here's a good rule of thumb to remember. If it's in your head, put it on the paper. Again, if it's in your head, put it on the paper. Because sometimes someone else who's looking over your work likes to just get in your head, and they can't do so if it's not on the paper. And that's how they'll better be able to help you. So you put it on the paper by recording all of your equations, your representations, and facts that you use to solve the problem. Last but not least, we're headed to the E. Headed to the E here, and MOL stands for evaluate. It stands for. So now when you evaluate, you're doing a few different things. One, you're going to double check your work using a second strategy. That is always helpful. 2, if it's multiple choice, you want to eliminate incorrect responses with reasoning and then bubble in the correct answer. When we talk about eliminating incorrect responses with reasoning, that means we are writing a little note next to that answer choice about why it is incorrect. And then lastly, we can always push ourselves by explaining our thinking using math race or other representations. So now that we just reviewed MOL, I'm super excited for us to practice it with a story problem. It's right there waiting for us, but not quite yet. We need to go over a few conceptual keys. We're not going to go over all of them, but we will go over 3 today. So when we think about conceptual keys, we know that there are action keys and then relationship keys. With action keys, we're thinking about a change over time. We're thinking about A. And then sometimes this action is indicated by a verb. So maybe that verb might show you what the change over time, but we always want to read carefully and just ask ourselves, is there a change happening over time? Relationship keys, there is no change happening over time. The numbers are just related to one another. So let's go ahead and look at that. So our first action key is a join key. Your turn again. With join keys, here are our knowns and unknowns. It's a start, a change, and a result. An example key will include these three components. For example, here, start is 8 minutes. The change, we may not know it. We can use a question mark, a box, or a variable. And then R, which is the result, was 15 minutes. And then this is how we would put it into an equation. Notice we wrote the letter of each component of our key underneath it just to remind us about how our equation matches our key. So now let's look at the problem that goes with this key. So Joel has 8 markers. He got some more markers from his friend Elijah. And then he had 15 markers. How many markers did he get from Elijah? When I think about this problem, I need to first ask myself, is there a change happening over time? What are your thoughts? Yes, there is a change. Joel started with only 8. And then at the end, or the result, he ended up with 15 markers. So that means that this change allowed him to grow over time. And so that's when we use join, when we're seeing that there's something growing. So we use addition to represent this action. All right, so let's head over now to our next action, which is separate. When we look at the knowns and unknowns in a separate key, the components include a start, a change, and a result. But let's think about how is this different from a join key? Let's read the problem. Jaden had a rope. I'm visualizing a long rope. He cut 10 inches off the rope. Now he has 5 inches of the rope left. Okay. How many inches of rope did Jaden have to begin with? Well, when I read this problem, I'm first going to think about, is there a change happening over time? I'm curious, what are your thoughts? Oh, so I'm hearing you say that you're noticing that there is a change because Jaden is cutting. Let's visualize that some more. Well, if you're cutting something, is that going to result in a change that grows or increases, or is that going to result in a change that makes something smaller and then decreases? Yeah, it's going to make something smaller and decrease. So if we know that, then this is a separate because we are taking away here in this in order to make something decrease or get smaller. So when we think about this problem, we see here that he had a rope. We don't know how long the rope was, but we know he had a rope. And then he cut some off, which is, he cut 10 inches off. So that's our change. And then what did he end with? Yes, 5 inches of the rope left. So we'll use subtraction, and this is the example of our equation. Start, unknown, the change was 10 inches, and then our result was 5 inches. Now let's switch gears and go to our relationship. Remember, relationships, there are no changes over time. The numbers just have some kind of relationship or they're related to each other in some way. So if we think about action or our first relationship, it's going to be part, whole. And here are our knowns and unknowns. We have a part 1, a part 2, and then a whole. We may also encounter multiple parts, right? There could be 4 or 5 parts, who knows? It's about how we read the problem and see what's known. Let's go ahead and look at the problem. There were 5 boys on the football team and 6 girls on the football team. I'm liking this football team. How many kids are on the football team? Well, is there a change over time? No, there isn't really a change over time. There's no verb. We're not seeing anything really grow. We're not seeing anything get smaller or decreasing. So how do we, talk to me about the relationship. How do we know that there's a relationship here? Okay, so we're seeing a part and a part, and then all of these, the boys and the girls, they represent the parts, but at the end of the day, they're related because they're all kids. And we see that in our problem here where it asks how many kids are on the football team. So when we think about solving this problem, we are going to be making sure that we're thinking about part, and whole. But let's look at another example. There were 11 kids on the football team. 6 of the kids were girls. How many boys are on the football team? So now we see what's different between this first problem and this problem. The numbers are still, the kids still share the same relationship for their kids. But now this time we're starting with the whole, which is 11 kids. And then we're going to find each part. So one part is going to be girls, and then one part are going to be boys. So there, the operations change. In the first example, we're doing addition because we're trying to find the whole. And in the second example, we're doing subtraction because we're starting with the whole and then trying to find a part. So the big idea here is that we can use addition to represent the putting together of both parts, or subtraction to show that the parts are being removed from the whole. That was a great review. You are a rock star. So now that we have reviewed 3 keys that we can possibly use today, let's head over to a guided practice. And without solving, I'd love for you to label each problem with the key you would use to solve. So this is where you'll pull out your marble notebook and you can just write 1, 2, 3, and then next to it, you'll have an opportunity to write down the key you would use to solve. Remember, don't solve. I'll read each one out loud to you and you write down which key are you thinking. Here are your 3 options: join, separate, or part whole. Let's read the first one together. Miss Chin bought 10 new flowers for her garden. At the flower shop, the owner gave her 3 additional flowers as free samples. How many flowers did Miss Chin leave the store with? Okay, write down which key you're going to use: join, separate, or part whole. Let's look at example number 2. There were 12 geese in the pond. 4 of the geese are brown with black spots. The rest of the geese are white. How many geese are white? Okay, join, separate, or part whole. Write it down. Last example, Lorenzo baked cinnamon rolls for his baseball team. His team members ate 8 of the rolls. He came back home with 4 rolls. How many cinnamon rolls did he bake? Jot down, join, separate, or part whole. Perfect. All right, now let's review. For the first one, that was join. Good job. Give yourself a check. This next one, what do you, part whole? Yes, before I even got to say it, you told me. And in our last one, what are we thinking? Separate. Yep. We did not know how many he started with, but we know there was a change and then it ended with the result of 4 rolls. Those cinnamon rolls must have been yummy to their tummy. So now that we tried those examples and just tried working with our keys, we're now going to look at an example together on page 4. And so for this example, we're going to combine mole and also our knowledge of conceptual keys to set up and also solve this problem. While you turn to page 4, I'm going to put on the big screen. Awesome. So let's go ahead and read our problem aloud. And I'm going to read it first for the first time. Remember, with M, I read it 3 times. Let me go ahead and choose my flavor. All right, let's go ahead and read it the first time. And when I read it the first time, I'm going to make sure that I'm visualizing, creating, and thinking in my head to help me understand what's happening here. Samantha is throwing a dinner party to honor her grandparents. She baked 68 cupcakes for the party, but 24 of them burned, so she had to throw them out. She decides she will buy a pack of 48 assorted mini cupcakes to replace the ones she threw out. How many cupcakes will Samantha have for the dinner party? Well, I'm thinking about this problem and I read it for the first time. So now let me visualize it by thinking about what is happening. Well, I'm going to imagine that this is a baking tray. And in the baking tray, I knew that Samantha, she baked lots of cupcakes and here are the cupcakes. Now she baked them, she pulls it out of the oven and she realized, oh no, burned. Yikes, burned. So she threw those out. Okay, so some of them are gone now. But then Samantha now, she's creative and she realized, well, yes, I had to throw some of her cupcakes away, but she can go buy some more. So she goes to the store and she buys some more cupcakes. So this is going to be represents the more cupcakes that she bought. And then now I know I'm here. She's trying to figure out how many cupcakes she'll have now for the dinner party. All right, so now that I visualized that, I understood it. I used some props to help me, and I also applied some of my own background knowledge around what it means to bake cupcakes and then throw away the burnt ones because no one's gonna want that. I get to now mark it up. So I'm gonna mark it up using Cubs. What does the C stand for in Cubs? Yes, circle of numbers. Let me go back and circle the numbers. 68 cupcakes, and then 24 of them burned, and then she has had 48. Perfect. Now, what does the U stand for? Underline the units. The numbers can mean anything, but we know what the numbers stand for when we underline them. So she baked 68 cupcakes for the party. 20, I'm gonna underline of them because I know this is referring to cupcakes. And then she bought 48 assorted mini cupcakes. Assorted means that it's just a different kind of combination of flavors. So it might be chocolate and vanilla mixed together, but that's what it means to be assorted. So we did the C, the U, what's next? B. What does B stand for? Bracket the question. Let's go ahead and bracket it. How many cupcakes? I'm gonna underline that so I know that the unit. Will Samantha have for the dinner party? Check, check. Now what's our last part? Yes, we're going to have to write our final answer sentence. I'm gonna put this down a bit. And go ahead now and write your final answer sentence with me. I'm going to write FA, which is going to stand for my final answer sentence. Let me look back so I can keep my characters' names in it. I know her name is Samantha. Write with me. Samantha will, yes, you're writing with me. Samantha will have blank, because we don't know yet. We didn't solve it. And what's our label again? Cupcakes. I see you, don't worry. Cupcakes for the, and what's the event she's having? Yes, it's a dinner party. I'm gonna keep that language from the question, for the dinner party. Period, because it is a full sentence. Now to keep organized, I'm just gonna draw a line to split that. Great. So now we're gonna read this again because now we're at our third read. We just completed Cubs. I'm just gonna write a little checklist up here so I can remember. Check, 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 check. So now we're going to do our third read in which we're going to create our mini unknown box. So let's read this again. Samantha is throwing a dinner party to honor her grandparents. As I read it this time, I'm thinking through what is known versus what is unknown. She baked 68 cupcakes for the party, but 24 of them burned, so she had to throw them out. She decides she will buy a pack of 48 assorted mini cupcakes, to replace the ones she threw out. How many cupcakes will Samantha have for the dinner party? Well, in order to create my mini unknown box, I know the final unknown, and it's in the question. Let's reread that. How many cupcakes will Samantha have for the dinner party? I don't know that, so I'm gonna write that in my mini unknown box. Go ahead and draw a box. Good. And then now let's go ahead. I'm gonna do a little tiny box so I can check it off when I'm done. So I know it's number of cupcakes for dinner party. That's my final unknown. Number of cupcakes for the dinner party. Now that I have my final unknown here, I'm gonna go work backwards and just think about what do I need to also find in order to get here? Let's see. Samantha's throwing a dinner party to honor her grandparents. No new information there. I just know what the party's about. She baked 68 cupcakes for the party. All right, so I know how many she has. but 24 of them burned. So she had to throw them out. I'm gonna here. She had to throw them out. That's important to me because if she's throwing those cupcakes out, then what does that mean? Well, that's going to mean that we don't know how many she has after she threw them out. Let's see. She decides she will buy a pack of 48 assorted mini cupcakes to replace the ones that she threw out. So again, in that next sentence, it still doesn't tell me how many cupcakes she had after she threw some out. So I know that's my other unknown. I'm going to write that here. Number of cupcakes, I'm going to write CC, after throwing out. I'm keeping the words short here because it's just to jog my memory about what I'm solving for. So now we've just completed our M in mold. Really great work. Now let's go over to what letter? Yes, you got it. It's the O. And what does the O stand for again? We're going to organize this workspace so that it is clear for us to follow. So in order for me to organize my workspace, I'm first going to stop here and think, how many steps do I have? Yes, only 2. So that's a big idea I want to remind you of. The number of unknowns that you have also tells you how many steps you have. So when I'm going to split my workspace, I'm going to split it so that I have 2 areas to work within. So I'm going to try to split it right in half. Now that I've split my workspace, my next step is to make sure that I have a title for each workspace. Guess what? Here's the biggest secret I can ever tell you. For the title, you can just take the words from your mini unknown box and use it as your title. So let's go ahead and do that now. So my first step, step A, the title is number of cupcakes after throwing out. I'm going to write that. Number of CC after throwing out. All right, and then now for B, go ahead. What is going to be the title for B? Yes, you remembered. There's no new work that you have to do in coming up with the title. Use what you already planned. So B, number of cupcakes. I can use CC here for dinner party. Now that I have my titles, what's next in my O? You can use your poster on your paper to help you. Yes, tell us, Aiden. Yes, going to our key. Do you agree, Michael? All right, so let's go ahead and create our keys. So I'm going to keep my workspace very, very neat. So what I'm going to do now, I'm going to just start with A. And I'm going to think back to it. And I'm thinking back to the story problem and think about what key would I use here? Well, let's go back and reread. Samantha is throwing a dinner party to honor her grandparents. She baked 68 cupcakes for the party, but 24 of them burned, so she had to throw them out. Is there an action or relationship happening between those 2 knowns? It is an action. And why? How did you know there's an action? Yes, because you're taking away from something. There's a change happening now over time. And then did you spot a verb that's also confirming that there's an action? Yeah, she's throwing them out. So if you think about this as an action, there's a change happening over time. Which key would you use? Talk to us, Brittany, Ashley, Samantha. Yes, we would use key separate. Let's go ahead and write our key. So I'm going to write key. And I'm also going to write the name of the key, separate. Now I'm going to draw a line so that I can save the rest of the workspace. Let's go ahead and think about our key for B now. Well, let's keep reading. She decides she will buy a pack of 48 assorted mini cupcakes to replace the one she threw out. Well, what's happening here? Is there a change over time, or is there numbers that are just related? Yes. Yes, Sanaya. Okay, Devin. Okay, I agree with what Sanaya and Devin are saying, and I also agree with what you're saying because I heard you too. Here, we're seeing that, well, she's buying a pack and she's going to replace it. So now whatever number that she got after she threw those cupcakes out, she's now going to be adding to it and it's growing now. That's a change over time. So when we think about our key here, you nailed it. This time it's going to be join. So I'm gonna come over here to this workspace and draw a line again. And now I'll write my key, and let's write the name of it. It is join. And I'm gonna draw a line down here to keep it nice and neat. Now that we have our key names, we can go ahead and we can solve. So key separate, I know the components are start, change, result. Let's see what our knowns, what we have. She baked 68 cupcakes, that's my start. Let's write it. 68 CC, always include your labels. Now the change, 24 of them were burned, so she threw them out. So that was our change. Let's write 24 CC. And then do we know the result? That's our unknown. So let's go ahead and do a box to represent our unknown, and I'm still gonna write a label. Great. Now I'm gonna separate that space because I still have a little space underneath it, and that's where I'm gonna write my equation. I'm gonna write EQ for short. Giving you a chance to do that now. All right, let's write our equation. First, I'm gonna just set it up so I have the components listed underneath it. Start, change, that's going to equal a box, which is my result. Now I can fill in using the values from my key. Start 68, my change is 24. Perfect, now what's next? We can solve. So let's go ahead now and solve. And I'm gonna draw a line under here. So now as I'm solving, we are in our L. If it's in your head, write it on the paper. So let's go ahead and write it down. 68 cupcakes minus 24 cupcakes. Let's go ahead and solve. 8 minus 4, 4. 6 minus 2, 4. 44 cupcakes. This is when we now are going to do almost like individual mole steps within each step to help us go ahead and double check our work and completely solve. So I'm thinking 44 cupcakes is my answer for this step. Before I confirm, I want to double check. So this last space, I'm gonna write DC, which stands for double check. It stands for, so how can I double check a subtraction? Yes, I can use the inverse operation. Big fancy words. And what is the inverse operation here? Addition. So let's go ahead and set it up. So this is my difference. I'm gonna take my difference, 44 cupcakes, and add my subtrahend, which was 24. And let's see if I come back to the minuend, which is 68. Let's see, 4 plus 4 is 8. 4 plus 2, 68 cupcakes. So this is my final answer for this step because I was able to start with my difference and get back to my minuend. Let's head over to step B. Silent excitement, this is so much fun. All right, step B, we said the key was joined. Well, since this is another step, I'm looking. I'm gonna write start, change, result. And now I'm going to look back at the problem and also look back at step A to see if there's information that I have to take from both places to help me fill in my knowns. So here's the start. What is the start? Well, I know for this step, it's taking place in this part of the problem. Let me go back up to it, where she's thrown them out. We figured out how much she has after she threw them out. And then she decides she will buy a pack of 48 assorted mini cupcakes to replace the one she threw out. So now I know that when she is replacing with those 48 cupcakes, she's adding on to the amount that she has after she threw it out. So now this becomes my new start for this part of the problem because this happens here at this sentence in the problem. So let's go ahead and write that over here. And if you like, I'm going to draw a little arrow to show that I'm bringing it over to my start. So let's go ahead this start is 44 cupcakes. And then now what's the change? It was those 48 extra cupcakes from the store. And then the result, do we know how many cupcakes she has after? I'm gonna use a question mark this time. Question mark, cupcakes. Right underneath it, before I forget, let's write our EQ. And let's start by first just labeling the components. This is a join key, so I know I'm going to be adding. Start change is going to equal my result. Now I can use my values from my key to fill in each part. The start, 44. The change, 48. The result, question mark. Let's head over now to the solve. All right, so we had 44 cupcakes plus 48 cupcakes. 4 plus 8, there's some regrouping involved. That's 12 cupcakes. So I'm gonna go ahead, write the 2 ones, and I'm gonna regroup that 110. 1 plus 4 is 5. 5 plus 4 is 9. So now I have 9 tens here, so I have 92 cupcakes. I'm not gonna circle this yet. Why? Because now we're in our E room. We wanna double check our work. So I'm gonna draw a line. And then what letters can we use to represent double check? DC, absolutely. All right, so let's double check. What operation can you use to double check your addition here? I hear you from all the way over there, wow. Okay, so we could use subtraction, 92 minus 48. And let's see what we get. Well, here we're going to have to borrow. I do not have enough units to subtract. This becomes a 12. So what does this next unit become? An 8, because we're taking 1 away. So then now here, let's go ahead and actually subtract now from our ones place. 12 minus 8 is how much? Yes, 4. 8 minus 4 is how much? Yes, 4. Let's see. 44, 44, yes. 92 cupcakes is my final answer. Now I can go back to my final answer sentence and write it in the line. 92 cupcakes. We just completed all of our work. So now let me go back to our E and do my final E by checking off that each step was completed. So check, I accomplished that. That was 44 cupcakes. And then check, my final answer was 92 cupcakes. Good job. So let's go ahead now and review all that we just did, because that was a lot of thinking that we did on paper. So now that we just reviewed MOL, it is going to be your turn to go ahead and have an independent practice. And we're just going to get to celebrate the sweet, sweet goodness of math wherever you are. So here are some problems to help you. Take the next 15 minutes. Feel free to pause this video so that you can work on those problems and go through each step of MOL with your problems. Can't wait to see. You have your units, you have your final answer sentence, and you did not forget to double check. Excellent. So now that you've finished with your independent practice, it is time to go to your exit ticket. So for your exit ticket, over the course of the day, we just learned a lot. We reviewed MOL and how to use our conceptual keys to help us understand and solve multi-step word problems. Now you get to show what you know on your exit ticket. After you finish your exit ticket, remember to submit that as your deliverable to your teachers on Google Classroom. And then do not start your story problem. Wait for your Zoom time with your teacher to work through your story problems. This was so exciting. This was fun. Thank you for coming to the Moltastic Ice Cream Parlor. Math, how sweet it is. See you next time.